Leukocytes are a nice fancy name for white blood cells, and white blood cells travel in the blood to arrive at whatever destination they're trying to get to. In addition to circulating in the blood, they also circulate in the body using the lymphatic system, and we'll talk about that later on in defenses when we talk about the immune system. Unlike red blood cells, though, white blood cells leave the circulatory system in order to migrate to a spot where there's a potential infection. So say here in this image, I have this white blood cell here. Looks this guy's rolling along, and due to some chemicals that guy might receive, he will go ahead and adhere to the endothelial wall of the blood vessel and leave to a site where there may be a potential infection. There's a bacteria here, symbolized by those green dots, and that white blood cell, that leukocyte, wants to go ahead and attack that potential harmful substance that could be in our bodies. So they're little defenders, and they can leave the circulatory system to elicit what's known as an immune response. We'll talk about this. These are the leukocytes found circulating in our blood. They're going to be categorized as either, let me get my cursor here, as either, where's that guy? There he is, granulocytes, and these guys, there's three of them. We'll talk about them. Basically, it's a nice fancy name just to say that they have granules in them, and this picture doesn't really do it justice, but when you see it on a blood smear in real life, there are these dots, very fancy looking, prominent dots all through. I'm not talking about these big dots right here. I'll talk about that in a bit. But these little dots, they're very tiny, little granules is what we call them, and this guy has really cool granules. These are the granulocytes of blood. Those that lack granules are categorized as agranulocytes. So let's go ahead and talk about the different white blood cells. First up is the neutrophil, and if I get a blood smear from anyone, they are going to have an abundant amount of neutrophils. This is the most common leukocyte. About 50 to 70% of our white blood cells are neutrophils. So I'm not going to have you guys remember the percentage, but I do want you to know that this guy is the most abundant. It has what's called a multi-lobe nucleus, and it actually lobes quite beautifully here into different sections. Neutrophils are responsible for mainly combating bacteria and fungi in our bodies. So whenever we have a bacterial infection, for the most part, I would imagine that these guys would skyrocket in our bodies in order to combat that pathogen, as I'll teach you. Here I see a cartoon of a neutrophil. It's this big guy right here. Let me minimize this so that you can see these images better. There we go. Here's a neutrophil, and actually they're the different lobes of the single nucleus, and I can actually see the granules in here as well. What neutrophils actually do, there's my bacteria, by the way, that green structure. What neutrophils do is actually performing an event called phagocytosis. It's one of the things that they do. And what phagocytosis is, as you guys will learn, is they basically eat up that bacteria. I think I have an image coming up soon. Next up are my eosinophils. Eosinophils also have lobes in their nucleus, and they have these really neat looking red cytoplasmic granules. Not a lot of our white blood cells are eosinophils, about 2 to 4%, but they still exist. They're not very common. These guys fight off parasites and contribute to the allergic response. Basically, we're talking about histamine being released from these guys, as y'all will learn in the immune system lectures. Histamine, that's what a lot of these granules are inside the eosinophil. And in this image, I'm actually showing you a parasite. Here's I forgot what it was. It looks like a nematode. And I can see those eosinophils attacking this parasite and preventing this harmful being from invading our bodies. Eosinophils will rise up in times of parasitic infection and in allergies. Basophils, coming up next. These weird looking guys, I've actually never seen one in real life because they're so rare. About 0.5 to 1% of the white blood cells are basophils. They're there, they exist, definitely, and they are responsible for contributing to the inflammatory response by releasing histamine, and you guys will learn about this more again in the immune system lecture. Okay, let's move on to the granulocytes. These guys lack granules, hence their name. And the first guy that's coming up is called the lymphocyte. Lymphocytes constitute a good portion of the white blood cells in our blood, about 25 to 45% are circulating. Lots of neutrophils, lots of lymphocytes are circulating our blood. And these guys actually look really cool in the blood smear as well. They all look really cool. Let me get my pointer here. They have an extremely large nucleus. It's not lobed, but it's quite large in this purple structure here, and I can actually appreciate how large that nucleus is. If you're wondering why the nucleus appears purple, why the eosinophil has some pink substances, it has to do with staining, whether they're acidic, basic. So it just has to do with what staining method you're using. Anyways, side note. So lymphocytes, very, very large nucleus. In fact, we have two different lymphocytes, T cells and B cells, and we will definitely discuss these when we hit up adaptive immunity. Last white blood cell is the monocyte. It's about 3 to 8% of the white blood cells circulating in our blood are monocytes. Monocytes are basically the precursor to macrophages. And actually, yeah, I do have phagocytosis being shown here. So macrophage is really neat, and monocytes too can perform this too. Both monocytes and macrophages are really neat in that they undergo phagocytosis. And what that is cellular eating. The cell itself actually engulfs surrounding microbes. I can actually see this is bacteria. Yep, this looks like bacteria to me, and I can actually see this guy engulfing, eating up, yum, 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 all that bacteria. And what it does is it actually surrounds it, takes it in. These digestive enzymes inside that cell actually kill and digest it, breaking it apart into different substances, releasing it. And basically, it'll turn into waste, which will be excreted from our bodies.